Imagine staring into a mirror that doesn't just reflect light, but time itself, not your own reflection, not the face you know, but the infancy of the universe. A moment when existence was still wrapping itself around its very first breath. That's precisely what the James Webb Space Telescope was built to do, but what it found when it looked deeper than anything before wasn't infancy. It wasn't the cosmic cradle. It was a contradiction, her cosmic impossibility. And what Webb revealed has not only stunned astronomers, it has shaken the very skeleton of modern physics. For decades, scientists believed they had the universe's timeline mapped out. First came the Big Bang. Then, a dark age of silence. After that, the slow and methodical birth of stars and then galaxies, and eventually life. The further back we looked, the simpler things should have been. Basic particles, faint hydrogen clouds, chaotic, unformed space. But when Webb turned its golden mirrors toward a quiet, empty sector of the sky, one of those vast black stretches we thought was almost barren, it captured something that should not have existed. A galaxy, not primitive, not faint, but fully formed, rotating arms, dense clusters of stars, a monstrous black hole at its heart. Not just alive, thriving. And then, more appeared. One after another, data revealed galaxies that were already mature, already structured, already chemically rich. It was as if the cosmic clock had skipped billions of years, and with every new image, one terrifying question echoed louder. What if everything we thought we knew about the beginning is wrong? The first time Webb captured one of these galaxies, over 13 billion light-years away, astronomers expected nothing more than a faint smudge of ancient light, barely distinguishable from the noise. Instead, what stared back was elegance, spiral arms curling like ribbons of starlight, dense clusters orbiting in harmony, a glowing core alive with energy. This galaxy wasn't in the process of forming. It was formed, and not just barely. It looked like something billions of years older than it could possibly be. To understand how shocking this is, you need to know how galaxies are supposed to evolve. In the early universe, matter was scattered and thin. Gravity slowly pulled it, together into clouds, which collapsed into stars. Over eons, stars grouped into galaxies. But Webb suggested this entire process had already completed, far, far too quickly. It's like planting a seed and immediately finding a towering, ancient redwood tree. And it wasn't just one anomaly. Across the sky, Webb found galaxies that were gravitationally stable, chemically mature, and impossibly complex. The telescope wasn't wrong. Our theories were. Then came the spectral data, the light signatures that reveal which elements galaxies contain, and with it another shockwave. These galaxies weren't just made of hydrogen and helium. They carried heavy elements, oxygen, carbon, even iron. But these elements don't exist at the start. They're forged in the hearts of massive stars, and only after those stars die in supernova explosions are they scattered across space. That cycle takes time. First-generation stars, population 3, burn hydrogen and helium. Then they die, scatter their contents, and only then can new stars form enriched with heavier elements. That process should take hundreds of millions, if not billions, of years. But Webb found galaxies less than 400 million years old. Already. Showing the fingerprints of multiple stellar generations. Not once, but more than once. The early universe wasn't quietly waking up. It was sprinting, forging, burning, exploding in ways no one predicted. And these elements aren't just the ingredients of stars. They're the foundation of planets, of atmospheres, of life. To find them so early is like discovering a thriving coral reef at the base of a volcano that erupted yesterday. The timelines don't just feel rushed, they feel broken. But then came the discovery that defied all reason. In the center of one of these galaxies, Webb detected a supermassive black hole, over 1 billion times the mass of our Sun. Today that would be astounding. But in the early universe, it's cosmologically absurd. Black holes are supposed to grow gradually. They start small, then feed on stars and gas for billions of years. But even in the fastest growth models, nothing could explain how such a monster, existed so soon after the Big Bang. It was like meeting a fully grown adult who had been born only an hour ago, and yet the evidence was undeniable. The warped space, the energetic emissions, the gravitational pull. This black hole hadn't grown, it had arrived. At this point, scientists had no choice but to consider radical new theories. Primordial black holes forming directly from density fluctuations in the early cosmos, exotic particles or dark matter accelerating cosmic growth. But these weren't tweaks to our models. They were entirely new blueprints for reality. And then things got stranger, because Webb wasn't just finding galaxies, it was finding patterns using deep learning algorithms. Scientists discovered that the distribution of these galaxies followed a mathematical ratio, eerily similar to the golden spiral. This wasn't just aesthetic, it was structural. A hidden geometry spanning billions of light years. The spiral arms, the symmetry, the orbital distances. What we thought was random chaos might actually be patterned, predictable, like fingerprints. But fingerprints of what? A deeper law of nature, or something far more disturbing, evidence of intentionality embedded into space-time itself. And then Webb detected something in a place where nothing should exist at all. In a supposedly empty interstellar void, its instruments picked up faint chemical trails, not simple gases like methane or ammonia, but complex organic molecules, polycyclic aromatic hydrocarbons, the building blocks of amino acids, the seeds of life, and they weren't bound to planets. They weren't swirling in stars. They were drifting, untethered, yet intact after 13 billion years. The implication was staggering. It meant that the ingredients of life weren't formed later in places like Earth. They were seeded into the fabric of the cosmos almost from the start. Life, it seems, wasn't a fluke. It was a feature, and then became the image that silenced even the skeptics. Deep within a cluster of ancient galaxies, Webb captured something too perfect to dismiss. 6 galaxies, arranged like petals around a central core, spaced evenly, rotating in near-synchronized orbits. Astronomers called it the flower. At first, they tried to explain it as lensing, or a cosmic coincidence, but no natural model could reproduce its symmetry. It looked less like chance and more like choreography, as if the universe itself had arranged a message in light. But the most chilling theory wasn't about galaxies or black holes. It was about us. Because some physicists began to notice something strange. Certain Webb images seemed to change subtly over time, patterns shifting, details emerging or fading depending on how they were observed, as if the act of observation itself was influencing the data. It echoed the quantum observer effect, where particles behave differently simply because they're being measured. But what if this principle didn't stop at particles? What if the universe itself is responsive to attention? By building Webb, by peering into the cosmos with unprecedented clarity, did we uncover secrets, or did we wake something up? What the James Webb Space Telescope has shown us is not just about galaxies or black holes, or dust drifting through ancient light. It's about truth, a truth so vast, so ancient, and so intricately woven into reality that to glimpse it is to feel the scaffolding of existence tremble. We didn't just see the unimaginable, we unlocked it, not by force, but by attention, by daring. To ask questions no civilization before us could. Galaxies too mature, chemistry too complex, patterns too perfect, signals too aware. Webb hasn't just shown us that the universe is more mysterious than we imagined. It has shown us that it may be aware of our imagination. Maybe we didn't find the edge of the universe. Maybe we found its memory, and maybe it remembered us. So the question isn't, what did Webb see? The real question is, what saw Webb? If this left you shaken, if the patterns felt too sharp, the timing too perfect, the revelations too synchronized to be random, you're not alone. Subscribe, because we're not just watching the stars, we're watching the response. Turn on notifications, because the next signal may already be incoming. And share this video with someone who still believes the universe is silent. Now comment below. What do you think Webb saw or woke up?